Well, good morning, everyone, and thank you for being here. So today's talk is about multimodality and why I think it represents a fundamental shift in how we build intelligence and not just an incremental update. But in order to understand the importance of multimodality, I'd like to ground it by first discussing the highest level of intelligence that we know to date, which is in this room, which is human intelligence, right? Sorry, let me go back. OK. I woke up this morning in my hotel room, still with jet lag, to the sound of my alarm clock, right? It's 3 a.m. in California right now. I smell like brewing tea. I saw the sunlight through my window, and then I could feel the texture of the floor with my feet. So we live in this very rich multimodal world. We continue to process, our brain continues to process a constant stream of sights, sounds, smells, and signals. And somehow, it can weave all of this information together seamlessly. So for example, if we hear a horn in a car, we know that the horn comes from the car that might be approaching us too soon. So this is very beautiful, highest form of intelligence, and we take it for granted. Now, in computer science, one of our major goals or holy grails is to try to replicate this intelligence in a silicon-based system. Now, in order to do that, in our quest to do that, we literally turn sand into silicon chips. We build intricate systems, mechanisms to try to replicate this intelligence that we have, inject this into like a machine, right? And so in the past, traditionally, there are like two schools of thoughts on like how we're supposed to do that. The first one is based on rules and logic. So people in the past tried to program rules into the system. For example, if you're given a question, right, how are you supposed to answer, hey, who's your name? Like, what's your name? What's your name, right? Rules and logic built it into the system. And then people quickly realized that, well, this system works really well in smaller scale. It cannot build a general purpose system because in practice, there's just too many possible scenarios that you need to face, right? So for example, you might be asked, how would you respond to your friend who jokes like sarcastically, right? It's very difficult. Like, do you need to design everything like that? How would you operate in a rainy condition as opposed to a sunny condition? Now, a different camp, a different group of people took a completely different approach to try to produce this intelligence. They actually built a system that can learn. So the approach is that instead of programming rules into the system, you want to build a system, a machine that can learn, right, from a lot of data. Now, for the longest time, this approach also didn't work really well. Because while, yes, we have a lot of data, we don't really know, how to make the best use of this data. Sorry. Or we don't even know, what kind of system to build, like a learning system to build that can make use of this data. But then suddenly there's a breakthrough, right? So obviously over time there's a breakthrough, and we saw a first sign of a general purpose system with the invention of GPT. It works really well on a lot of cases, and it turns out what works really well is remarkably simple, right? So what we do is, so people just, feed the entire internet, essentially the entire internet to this machine, right? Then we have GPT. So obviously, this is like a ton of compute, massive amount that could even power maybe an entire village, small village, right? And then you throw it into this model, this system. And then, okay, it works really well. It could answer your questions, draft your emails, debug code, solve math problems, and even help me draft this presentation. Right? So this is the kind of systems that we have today. This is the text frontier that we have, a frontier built entirely on text. Right? And then, okay, the natural next step after that is we then realize, okay, this chatbot is great. It creates a way for us to interact with the machine in natural language, in multiple languages, in fact. And then we decided, okay, we wanted to be able to do more. We give it access to tools. Sorry. We give it access to tools, right? So now we created agents. It's not just a chatbot. It now becomes an agent that could interact with its environment. It could, for example, if you give it access to the web, if you ask a question, what's the weather like in Lisbon today? It would be able to, check the web. Oh, it's a bit cloudy. Be able to say it's cloudy, right? And even going a step further than that, you could do a lot more complex question. For example, go find latest research on reinforcement learning, like a topic of your choice, right? And create a summary for me, one-page summary, synthesize all the information and what the consensus is like about the best approaches in the field today, right? So this is what we have today, and it's amazing, it's remarkable, but it also, I think, has limitations. We hit the ceiling, and the ceiling is because we now run out of internet data. We have fed the entire internet. Sure, yes, we continue to produce new content on the internet, but the rate at which we produce new content, we write new content, is just not fast enough, to satisfy, the rate at which we want the system to improve over time. We want it to be better, next year, the year after, and then how much more content can we produce in a year, right? So that's the first problem. The second problem is now there's also so much AI-generated content on the internet. So it's almost like this powerful system is learning from its own output, its own biases, hallucinations, mistakes, this data pollution. It just makes it less clean and robust in terms of the learning process. Now, where do we go from here? What is the next step in capability? We believe that the answer is in the abundance of multimodal data. So every second, there's a lot of multimodal data that is being produced, a bunch of videos being uploaded to the internet, bunch of footage being taken, cameras, from your phone, being taken videos, bunch of cameras in the building, sensors, microphones, right? A lot of multimodal data like this. And our vision or the idea is to move from learning from the internet to learning from the physical world by using all of this multimodal data. Now, this raises a different question. How are you going to learn from a lot of this multimodal data? So obviously, we need a different kind of system that can take as input not just text, which is where the previous frontier was built on, but also images, video, audio, and other sensors, right? And then once you have all of this data, there's also this other question. How do you make the best use of this data, right, in this new multimodal frontier? So we have 4 key pillars in how we leverage this multimodal data. The first one, similar to the old model, similar to the previous approach, we still train it on internet data, right? So I think trillions and trillions of text tokens, predicting the next word. It's impressive, what kind of abilities that could emerge from just predicting the next word. We've seen it in the past. This allows systems that can converse with you in natural language. We think language is still a key scaffolding for your abstract thought. It allows you to learn logic, reasoning, and also a repository of knowledge from the world that is available on the internet, right? So this is the linguistic backbone of the model. Yes, like complete a paragraph, like predict the next token, that's still key. The next thing that we want to do is connecting this language with vision, right? So in this like phase, like in this step, like this like like category, what we ask the AI to do in the learning process is like predicting, describing what is in an image or like a video, right? For example, in this example, you'll see like, okay, this is an image of a traffic jam. It's in an urban setting. It seems like the condition is after the rain, right? So the AI will learn how to connect this. We'll build this like new vocab that connects this like concepts or that it has learned from like training on trillions of tokens to the internet data to pixels, like to identify, hey, this is what the traffic jam looks like. This is what the car looks like. Like it builds this like vocabulary that connects like your language vocabulary to pixels. So this is the next step that we can do. And then the third pillar is learning how to detect and locate an object. So you're not just describing, hey, this is an image or a video of a person, a male person, presenting like a topic, like speaking on stage, or like in this case, like in a construction zone, bunch of people building some scaffolding. But you also try to teach the model to locate or detect exactly where the person is. So in this case, essentially predicting the coordinates of like where the person is. Okay, this is like the person. You could ask like, where is the helmet? Like, or show me like the face, right? Or the hole in this case. So what this enables is now you have a model that can also learn, like have some sort of like spatial understanding, right? Because it doesn't just describe an image, but be able to locate and detect objects. And then last, I think the things that we do is also try to ask the model to reconstruct like videos. So in a different style usually. And in this process, you allow the model to learn some sort of like basic level of physics concepts. You'll know that when people talking, they try to move their hands, or when you drop something like an object, an apple, they try to they fall to the ground, even though they do not know the equation of gravity, they understand the concept, right? Or when you hear so that like the model would know that waves crash on the shore, or ripples, for example, propagate outward, right? This kind of like basic level of concepts. Now, obviously, when you combine all of this together, this is not easy, and there are like a lot of challenges, in particular around two things. Obviously, if you want to learn from a lot more data, you naturally need just more compute, because obviously text represents like some portion of the data that you want to train on. And then on top of that, you also have other multimodal data, all these videos, all these images, all this audio that you want to learn from, right? So obviously, you require more compute to take this approach. But also, like in order to find the right data, right? So what kind of data you want to train on, and what kind of annotation you want to provide to the model. Like for example, locating an object, like changing it to a different style. You need to clean the data, you need to align the data, you need to find, for example, if you want the model to learn that if a glass like breaks on the floor, shatters, like this is the sound, you need to find a video that has that. Among all this background music, maybe you need a video, like conversation, so you need to do a lot of data cleaning. But if you combine all of them together, when it works beautifully. And this is our vision, this is our word model. So it's like moving from, as I said, like not just like learning from the internet, but learning from the physical world. And the goal, the idea, is not to just have this kind of models that understand the physical world to be deployed in data centers. Yes, so we have like models that can process global data in data centers, but the idea is also to have hyper-efficient version of these models that can run everywhere, like on your devices. For example, on your phone, your car, your camera, maybe your smart glasses as well, right? So this is multimodal AI that you can deploy anywhere. And this is not just science fiction. The applications are already transforming multiple industries. For example, in robotics, right? So now you could, for example, build on top of this model, be able to tell your robot, hey, pick up the blue box like on the right-hand side, right? And like that I pointed. The robot does not have just to be programmed to pick up something, but it understands from your like natural language command. In other domains, like in defense security, so for example, I could ask my home camera system, hey, send me a notification if there is somebody who acts like suspiciously on my front door. Or maybe in disaster response, when you fly a drone over a disaster area, it would be able to report back, hey, I identify something that looks like a dog behind a pile of rubble. This could be the difference between life and death. You might want to check it out, right? And then in other applications, other areas, in automotive as well. So for example, for cars, this is just like beyond self-driving. Like maybe you'll be able to analyze footage. Like if somebody's driving and they suddenly brake, like is it because it's just they are driving recklessly, or because there is a kid suddenly jumping on the street, and you just want to be really cautious, like analyzing like driver behavior, safety, these kind of applications. And then in media entertainment, being able to search over millions of hours of footage, being able to like pinpoint exactly, hey, this is the moment I'm looking for. Maybe when somebody's scoring a goal, like in soccer, maybe when somebody's getting red carded. Being able to predict whether a short-form video is likely to go viral, whether this is suitable for like demographics in Europe, in North America, whether suitable for kids, or it processes like some sort of like brand safety risk. This kind of applications. And then lastly, obviously in wearable devices, Internet of Things. How often, for example, you go to a grocery store, you have your like grocery shopping list, you look at the shelf, you're not able to find exactly the item you're looking for. If you wear these glasses, maybe it would be able to identify it for you. Okay, this is actually the item in your grocery shopping list, right? So so this is the frontier. This is the frontier that we're all building together on, and this is what we envision. Thank you.